And tonight I'm going to do one of the examples that I usually start the semester with, our box with a hole in it. And at this time of the semester, though, we're really going to be more interested in going through the list of mates. Right, so we're going to be able to possibly generate some, let's see, we're going to be able to do the cam. All right, so some of the mechanical mates we may not get into. Trying to think where I can, what I can do quick to apply those, but all right. So 3 inches, and then we'll go to center rectangle. All right, and 8 inches is fine. 1 inch thickness. And we'll save that somewhere where I can find it again. All right. So in the assembly, we open up the assembly module. If your begin assembly is set to start command when creating new assembly, you're going to get this interface, and that's going to let you pick anything that is open or browse to another location. All right. Once I go to the file, just kind of as review, if I hit OK, it's going to align origin to origin. As soon as we come out and we start flipping things around with the box for rotation, doesn't quite go origin to origin again. All right, so at that point, I might as well just get it close and place it in position. All right, it's still going to fix. It's the first part, and so we're going to float this because I do want it in relation to the origin. Unless I'm going to create that coordinate system, any mass properties, mainly the center of mass calculation, is going to come off of this origin when maybe this is really the base that I need or would want. All right, so we want to make sure that we have that first selection. All right, so going through the list, I'm going to go plane to plane, and then we'll go. Let's just keep going plane to plane, top to front, and right to right. All right, and those are going to put now the origins. All right, the little blue dot, one's facing this way, one's facing this way. Well, I rotated my part. And in the process of doing all that rotation, this origin is pointing in the direction of the part, where this origin is the direction of the assembly. Since little blue dots kind of tend to annoy me, once I have that first orientation set, I'm not as concerned. So we're back to just looking at the parts in relation to my base piece. Easiest way to bring in another instance, Control Select and drag. Recommendation is still bring in one part, mate it as far as you can get the relations to go before you bring in another part. If you keep bringing in parts, hold down the control button, you're going to create a little bit of a headache. All right, so tab button hides. So at the very worst case, I would not want to see those even after I drug everything in, and until I get to that point. On the assembly then, insert components. The pull down does the same thing. New part, new assembly will create top-down strategy, in context related parts or assemblies, sub-assemblies. And then let's see, also the insert component, existing, new part, new assembly, same thing that we just looked at. Dragging from the Explorer, the File Explorer, things that are currently open, going to your desktop. We can drag and drop into the to the work area. Let's see, if we have Windows Explorer open and minimize the screen, well, okay, shrink the screen a little bit, I could drag this whole assembly into my current assembly, and all of a sudden this one's an upper level, a top level assembly. All right, so, and this just became a sub-assembly. So you're pretty much going to be responsible for tracking how you want to order your top level assemblies, sub-assemblies, sub. You know, however deep it gets into the mix. All right, so once you have the parts in, then let's go with the standard. We'll go face to face and coincident. And if I go face to face on the cylinders, that's going to go to concentric. That's also going to leave me 1 degree of freedom for rotation. If I want this to rotate, then I'm fine. If I want this instead to be limit, now in this case it'd be a limit angle because of the rotation, then I would want to look at that geometry as, let's go face to face, and we'll go into the mate. Anything that goes beyond setting a hard number for the angle, you're going to jump over to the next tab, Advanced Mates. And Advanced Mates, as soon as you pick either a limit distance or an angle, it's going to show you this is the current position, this is maximum value, minimum value. And the current position has to be in between the max and the min. So since we're at 180 degrees and I want this to be able to rotate 90 and, well, I was going to go negative 90, but it got up to me a little too soon. Based on the 180 degrees, I would probably put in 270 over a negative 90. All right, if there's going to be a problem, it's with the mate as you're dragging other things around and as the stack up gets more complicated, negative numbers are a likely culprit when you have over-defining conditions or errors generate. All right, so the test is we can go 180 degrees of rotation, positive to negative 90. Clicking back into that, if I go from 180 to 270, oh, let's try that again. Oh, I went the wrong way. Max condition 270, min condition 90, big number to small number. We're going to get the same result, but because they're both positives, there's not the same likelihood that it will try to reverse signs or do something strange later on. All right, so typically it would say that you want to design to a static configuration, that you build this in its theoretically perfect state. And we aren't really concerned about movement initially. After you've gone through the process, then we can worry a little bit more about making this more dynamic. So if I add a dynamic configuration, then that picks up the mate, and I would come back and suppress for the default and just make those coincident. And actually, coincidence is not really my preference there. Mainly I want an identifier. I don't use parallel that much, or where we do use parallel, it's kind of a flag. It's something that's recognizable. All right, coincident we're using all over the place. Parallels, hardly ever any perpendiculars, but that parallel looking down through that sequence, that'll be something that I notice. And if I really need to, I can rename it and say, look here. All right, and then I won't miss that one at all until it gets consumed in the rest of the mix. All right. So with the mates, I'll expand that out. Notice that this automatically reversed suppression states. because when I added the parallel, I was in the default, and when I switched over to dynamic, this was suppressed, and now this one's, they basically switched states. If I unsuppress this, it did throw an error. Sometimes the limit mates will not throw the error if it's part of the solution set. And if you force the mate, probably not a good idea. And the other one would be to, we're going to go back and just suppress it again. All right, so being able to manage those suppression states either out of configurations, or worst case, we're going to go back and suppress one and unsuppress the other, and then now I'm confused as to which one I really need, and going back and forth is not going to be as easy as just saying default dynamic. All right, and then the dynamic is capable of moving. All right, so I think I want to stay in the default. All right, adding in the next one will show. All right, let's go with coincident on the edge, and then I don't really have a hinge, but if I treat this as a hinged edge, I have rotation, and I have too much rotation. All right, so this is one of those cases, and the linear will be able to do kind of the same thing. Is to figure out where the collisions occur. So if I'm moving the component, under move component I have collision detection, and I'm going to pick two components, so the box and instance 3 and instance 2. And when I resume drag, it's going to stop, and if my speakers were up, it would go doink or something, and then it would stop. All right, so that's telling me where I can physically move through the to the collision. Well, I know that that is either 0 degrees, and that's 270 degrees or thereabouts, or 180 degrees. So we don't really need to do the measurement, but since we're here, let's go ahead and evaluate, put the measure up. And when measure comes up by default, usually it is collapsed. So if all you get is this very first, you'll want to hit the double carets, and angle is 180 degrees. All right, so if I want to stop a little bit short of that, and again, I'm in the default, so my default setting, my static setting, would be more along the lines of a straight angle. Let's go 60 degrees. All right, so that's kind of the nominal position. That's where I would want to see it in most cases. All right, but knowing that it's capable of moving, when I come over to dynamic, and we're going to double check. So I'm going under each of the instances and looking at the mates in assembly, and notice that all of those went back to suppression when I changed over. The mates at the bottom is the big long list of everything, and this is going to grow and grow and grow and grow. This is going to be a behemoth. So going down through here and finding, except for the very last couple of things that you added, because they're now embedded somewhere up here, I hardly ever go to the mates anymore. Previous to having the mates folder, we searched and we put little placeholders and we made notes just like I did the look here. We did that in the mates so that we could identify certain items, certain mates within that group. All right, so I still want these two to apply. I don't want them to be suppressed, so when I unsuppress them, we have rotation. The limit angles hasn't been in place yet. So going into those two items, back to the assembly, we'll set the mate, go back into the advanced mates, and now we're looking at an angular distance. So I want to be able to go from minimum of 0 to 120 degrees. All right, just to have something different. All right. Didn't do the mate alignment. We'll catch up to those, but keep in mind that you can reverse and that has a slightly different effect out of the advanced mates. And flipping the dimension causes it to flip the other way. So if we've got everything pretty much aligned, we shouldn't have to do too much of that. But there's my 120 degrees. There's my rotation, open and close. And kind of naturally, it's trying to catch up from whatever I did the drag, because however much it can jump around, it's going to try to find that solution. So that jerkiness of the result is not really not really worried about it. All right, back to the default. I have the static, which is convenient to work to. I have the dynamic, which I'm going to test at various steps, and keep kind of going through that process. All right, so we'll show. All right, so we started off with the face-to-face, or plane-to-plane, and then we've done a couple of face-to-face. 2015 or 2016 is when they added the profile, and profile center says align and center. Okay, and there's a little bit more to it than that, but profile center goes fully defined. All right, so that one mate says that the area of this piece to the area of this piece, how do I want it to look? We're at profile center, offset distance if we need it, 1 inch. Kind of rotate it around. All right, so offset distance, shift it off some position. Is it capable of rotating? Let's see if we go back to 0, that's okay. Orientation, 90 degrees. And so you have quite a bit of power in the profile center, but you also lose some of the flexibility. All right, so I haven't really adopted profile center as my preference, mainly because I'm in the habit of coincident to coincident to coincident, and there's let's say it's a good process, but you have to use it to adopt it, make it part of your habit, part of your workflow. All right, show. All right, so we've done the limit angles. Oh, we need limit distance. All right, so let's go coincident to the faces, coincident to the outside. All right, a limit distance says, if we just set the distance, and let's see, we are in default, so just kind of looking up here at the flyout, I haven't saved yet because I'm still at assembly 1. The first item is my configuration, so if I'm not sure if I'm in dynamic or default, I can look up here and, oh yeah, it's default and it's display state 1. So default is controlling those suppression states. It's controlling physical attributes of the model. The display states are the visual attributes. What color is it? Is it transparent? Is it in wireframe? Is it something that you can see or has texture? All right, so not so concerned with the display states just yet. All right, so in the default, I want a distance of 1 inch between the first face and the second face. All right, so now nothing's moving, everything is still in place. We'll go over to the dynamic, and now that's capable of rotating, and those are not cooperating because of their suppressions. All right, so profile center, and we'll unsuppress. That one snaps back. All right, so worst case is when this snaps back, it kind of loses its alignment, or it loses its this orientation. Then we would just have to make the correction and double check it against the the default. All right, so I'll go ahead and unsuppress those as well. Now this is capable of moving. All right, so get it into a position that we can manage it. And then face to face is going to be a limit distance. So its current position is 1.5. Maximum will be 7 inches. Minimum will be to 0. So I have just a little bit of overlap. All right, so as long as this number stays in between these two numbers and we can manage the max and mins, then this is now going to be able to move. This is going to be able to rotate. And as the solution, as we go through the process, it's going to try to move in, I guess, whatever respect keeps that solution in the current view. All right, so things moving, this moving when I'm moving this is not a surprise, or shouldn't be a surprise. There are times where I would move this, and for whatever reason, this won't move. And then when I come back over and I grab that piece, now it's not wanting to cooperate, and there's going to be some selection, I hope. There we go. Some selection that I'm going to have to make to let it catch up to manage that movement. All right. So the dynamic can get pretty complex, which is why I'm going to argue have a default to jump back to, that it will keep track of your current position, and we'll just stay with assembly 1. That you'll always be able to return to that current position and then build out again if it gets too crazy. And used a little video processing power there because my fan just kicked on and lights dimmed and no. All right, let's see. We need to bring in another item. All right, let go too soon. There we go. So let's do profile center in a little different orientation. All right, so whatever is the area and the center of the area for the other piece, that's what it's going to apply for the profile center. It's going to let me rotate, and then that offset distance if it's needed. Okay, so we're having fun with these. Let's go with a concentric. We'll keep it on a line. And looking down through the mates, I mentioned that parallel is kind of if there's rotation with a limit distance or a limit angle, parallel would allow it to make that movement without the rotation or being able to control rotation. Most of the time, my selections are parallel or coincident. Very rarely do I find a need for perpendicular. But once in a great while, perpendicular shows up. Let's see, what did we do here? Okay, so we're concentric on the face. Tangency, on the other hand, we're going to have to bring in the bring in our pin. And then we've done distance and angle. Lock, kind of like fixed in the sketches. I don't lock. If I can't figure out the combination of relations to get a desired result, locking two components together just is kind of a haphazard solution in my opinion. So use it, try it, and then when you find errors, when you get the red explanation points and the yellow yield signs and whatnot, go back and lock or fix is going to be kind of at the base of those typically. All right, under the advanced mates, we did the profile center symmetric. Let's see. Yeah, probably not going to be a great example, but actually it was, since I'm jumping around. Let's see. Usually I use symmetric in conjunction with a plane, and the width is tab A into slot B. So fortunately, these are not great examples. So let me bring in another one. All right. Okay, so symmetric would be, I have a symmetry plane, and we'll make that the front plane. And then I need two faces, right? And the faces do not have to be on the same object. If I had another object over here, I could have those faces. Well, let's do that. All right, so this is going to put me symmetric to that plane, but probably establishing the symmetry. Let's see, let's turn off the move. We'll go to rotate and rotate, and we'll get starting of the orientation. All right, so we'll go back into the to the mate, find the symmetric mate, and make sure to go to the top. Our symmetry plane will be the front plane again, and then the two planes align. All right, so as this one moves up, let's see, what did I do? Okay, there we can see the symmetry, but it's one of those at the isometric. This one can move since I don't have a an X orientation or horizontal orientation. You know, there's times where it will move, but it's moving forward and back, not so much out and away. Kind of hard to explain that one. All right, and then if I were to go the other combination of those two and go back to my limit distance, and now I'm going to have my default all messed up. All right, so currently 15 inches. We will go to 24 and 0. And now they can move out and away, come to together. All right, so I'm still working on that one. All right, and this one needed. All right, so planes and faces are my preference. You can use edges and points. Probably the reason that I use faces is that they're easier to select. You're not looking for geometry. One of the things in the shortcuts was if you hit, let's make sure that one's it. Turn on my my filters here. If you hit the E key, notice that I am in a filter. I have a little funnel, and it automatically went to edge, E. All right, so if you're on the keyboard and you accidentally can all of a sudden only select edges, none of the faces, none of the points, none of the vertices, none of our geometry, it's because you have a little funnel on your screen and the E key, and there was another one that shows up as well that will select or deselect for edges. Oh, X. Filter faces. So let's go to X. All right. There's my funnel. I'm only selecting for faces. And to bring up the filter bar across the bottom was F5. Okay, so one of the issues with the edges then, let's just go edge to edge, and we did this with the limit mate acting as a hinge, is that these are going to be able to turn and move and do their little dance. And it looks neat, but what is the practical side of all of that movement? Can I really get it to go into all of those areas? Back to the physics. You are responsible for physics here. If it has gravity, if it requires water, power, air, oil, you have to provide it. Because as far as the software is concerned, two objects occupying the same space is a valid solution. Right? Only in our reality can that's going to need some better noises. All right, so let's see what else. Oh, yeah, I was working up towards the mechanical. Let's get into the width mate then. Bring in one more, and we'll slide that one in on the bottom. So let's go coincident to the face, and then we'll set a mate. And go to the advanced mates, and under width, it's going to ask you for width selection, tab selection. So always think of it in terms of tab A goes into slot B. Two faces on one part are set to the width. Well, I reversed it, but there's the tabs. And that will automatically center across that part, regardless of size, regardless of what changes I make to either of those parts. As long as this is a planar face and these remain planar faces, then I'm going to be able to keep that width, basically keeping it centered in that shape or on that face. All right, still capable of moving, not capable of rotating. So the last one would be to go point to face. Oh, and we're still in something. So let's jump back into the standard, make that coincident, and point will work as a possible solution. All right, almost Art Deco enough, and with all of the suppression in the dynamic, yeah, it's going to be kind of a mess when we jump back over to dynamic. All right. So what did we get to? PathMate. Linear coupler. I can't say that I've used that one, so that would be one I'd have to look up. But basically, well, we'll try it. I think that just by it being a coupler, well, we'll see what it asks for. Let's go to the PathMate first. And for the PathMate, we need a path. So in the motion study, in setting up cameras in the appearances, being able to go through this process of lighting and cameras and positions and all that, I have put cameras on a path and had it follow a path around, pointing at an object to kind of zoom and generate movement around a part. Way more complicated than it was probably worth, but it was a lot of fun. All right, so we're in the top plane. I need splines, usually good. And close. And I have my default spline. Oh, that's a really big spline. Okay, so a point, a path, and notice that I used a spline because this is going to be continuous. If I'd drawn arcs and fillets and lines, whenever it found one of those endpoints, it would have said, okay, into path, you're done. All right, so converting over to a spline or fitting a spline, generating the spline gives you a continuous path. All right, so we went continuous. And we'll go back to the path mate. And under the path mate, then you have constraints. You can go distances along, percentages along, how much of this path it will travel. Pitch and yaw free or follow the path. And then roll, because if we leave everything free and accept it, it's going to keep that point on the path, but it's also going to be able to do all kinds of fun movement as it goes through. But it is constrained. It is, the roller coaster ride that none of us want to go on because it's making me sick just to look at it. All right, so, but like I said, generating a point and a path mate and then attaching a camera to that point and keeping the constraint at an object or keeping the camera pointed at an object as you change the focal, the view, is an interesting way to generate kind of the graphic media videos. All right, so I think I'm going to expand out and hide those since they got a little big. We'll come back to them later. All right, so what I was working towards, let's see what it wanted for linear coupler. Oh, and what jumped into lock? Interesting. So apparently something was selected or I wasn't paying attention. And all right, so let's just clear the selections and see what it's going to ask for. All right. That's probably why I don't use linear coupler. Entities to mate. Reference components. Entity to mate. Now my curiosity is ratio of 1 to 1. So obviously movements in the parts. Nope, gonna have to go read the help file on that one because now I can really say I don't think I've ever used linear coupler. So I found something today that I didn't know. All right, so we'll come back to that one after I read the help file and ponder on it a bit, and then decide what I can really use it for. All right, so cam would be sort of like following the path mate, except that we're going to have a cylinder. Usually, a cam follower is going to follow its way around, staying tangent to the surface. So maybe the inside of the circle. Slot is going to stay centered on the slot. So usually you will have like a tapped hole or a some kind of fastener that is going to ride back and forth in the slot, and the constraint will either be centered in the slot, a distance along, or a percentage of the slot geometry. So since I didn't create any slots on these, well, we'll see what it picks up. Concentric selections and coincident selections. Usually if I need a hinge mate, I have already drawn the hinge, or I've already created a model for the hinge and the hinge works. So another one I'm going to have to look at. The gear mate, so gear ratio, would basically, yeah, let's go ahead and use this one. So we're going to have a cylinder, and whatever, well, this one's not capable of turning. whatever the first selection turns, we are either set to, and did it not pick up? Oh, it's doing it in inches, but basically the ratio is 3 to 1 or 1 to 1, or so every time this moves 3 inches, that one will move 1 inch. So teeth, diameter, so, well, can't really have one tooth, can I? All right, so if we're in teeth, so 30 teeth to 10 teeth, not sure if that works out on the pitch, but basically whatever this one turns, and that's not going to be a concentric thing, is it? All right, I'm not in alignment for a gear. These pretty much need to be tangent and would typically make the pitch diameters tangent so that when one turns, the other one's turning faster or slower. So, bad selection. Rack and pinion, kind of the same thing, as it's going to move back and forth on the rack. Pretty much the going to have a sketch for the pitch diameter and the pitch along the rack so that those two items are aligned in the mate. And then when you set up for the screw, it is revolutions per inch or distance per revolution. So revolutions per inch would be your threads per inch, or the actual pitch, depending on what you have selected. So for that one, that's kind of what I intended to do with these two. And it's showing the direction. And let's see, let's go, well, if I go 30 revolutions per inch, that's going to be there a while, so let's go with a number 8. So fairly large. All right. So let's put that in, or we can look at it. And not going to quite rotate, but it should be getting closer and further away as I make my rotation. All right, so the tool post had a good example of the screw mates. All right, but every time it rotates, it's going to move a little closer to the part. And then the universal joint. What is it asking for? Define joint points. There again, if I need a universal joint, chances are I've already created it. All right, so that moved. That's still capable of doing its and everything else. We lost the suppression. All right, so at this point, if I need these items, and keep in mind that under the dynamic, I would probably suppress these out so that I could find anything with a minus and determine how it's going to relate to the current document. And strange things will happen. And I expect eventually, if I move this enough, that screwmate will throw this completely out into someplace where we can't find it. Or we zoom out and you'll see two little dots where they got lost. Okay, and then unsuppress. Okay, well, oh. And we need both of those boxes unsuppressed for the mate to work. Okay. All right, so that brought the symmetric back, and then we can bring the limit distance back. All right. So enough fun there. I'll go back to the default. Yeah, or the pitch. So if you're dealing with standard, so imperial, inch, whatever you want to call it, I always use the example of the quarter 20. It's either 20 revolutions per inch or 20 threads per inch. And if you go to pitch, 1 divided by 20 gives you 50 thousandths. The distance per revolution would be 50 thousandths. If you're dealing with metric, the second number is the pitch. So an M6 by 1 thread will have 1 millimeter of distance, and revolutions per inch or revolutions per, we would just go to the distance because it's going to be easier than trying to back calculate. Okay, so. All right, so kind of an overview, let's say, of the more commonly used, or the ones that I use more commonly. You should be prepared to go through and kind of play with all of those mates. The standard mates are going to be, they're going to be in front of you all of the time, but be prepared to jump over into the advanced mates. I think Profile Center is one that I'll eventually start using, and with mates I use quite a bit, the limit and angles, but again, this is more dynamic. This is more what you're doing with that motion. All right, so rebuild and save. And before I forget, I want to go ahead and make the point that let's go ahead and open up another assembly, and I bring in assembly 1 into assembly 2. And all of the origins are on, so all of those blue dots, yeah, they're a little annoying. All right, so at this point, we're in the default, and I come up and say, oh, I want to be able to move this. I'm going to put it in dynamic. Well, whatever the last state of the dynamic, that's what I got. All right, so this is not capable of moving because we haven't told it to solve. And I don't think they've added anything up here, so it is still embedded under component properties. So the very top far right icon, component properties, will show you the display states, will show you the configurations. And then over on the right, suppression state is now resolved. And then underneath that is solve as. Right now it's set to rigid. It's not going to move. As soon as I switch it to flexible, don't need anything with envelope. Oh, and there are times where we would want to exclude this whole subassembly from the bill of materials. I can check to exclude. All right, so at this point, now I'm in my top level assembly and I have the flexibility. All right. As this gets more complicated, if this is driving something in this assembly, which is driving something in another assembly, we're going to have a lot of solving to going on in the background for our system, but it's going to be doable. So there may be times where rigid, well, and still being able to set up a configuration that says, okay, here's the dynamic top level, and we can always go back to the default. And now I do have one that's static. All right, so configurations kind of have that ability. Have that ability to go from level to level. What SolidWorks won't allow is a circular argument. That's something that drives the top level cannot drive the very lowest level. Okay, so I'm not going to save assembly 2. All right, so just we dealt a little bit with the configurations, looking at the display states. Then add a display state. Usually I will have a work in progress. And the work in progress says that I can have everything turned on. And then we'll go down the list of that. Let me hit a few on the tab. That. Oh, that one. All right, so I'm working in and around those 5 or 6 items, and then I get whatever done that I need done with those. I can show that one, hide that one. All right, at any time, I go back to display state 1. Okay, there is everything, and then jump back to the work in progress so that I can see the differences. So also with the display state 2, and if you add appearances, so this is going to be the component level of the assembly. And let's make this yellow. And then keep scrolling because it is this display state, all display states, or specified display states. So I could have this be more than one display state, but it's not always going to default to this display state. Most of the time it will. But there have been times where I've gone through a very complex, I want this color for this combination, and then it shows up in all of my configurations, or it shows up in all my display states, and it wasn't checked. We also talked a little bit about the transparencies. So let's see, surface finish was the color under illumination, diffused, specular, reflection, transparency amount. So 60% transparency on that one part. We go back to the work in progress, goes back. All right, so other things that we can do for our display state then is identify which component that is. It highlights over here. If I come away from the default, I can set this one to let's just go hidden lines visible. All right, so as it rotates, it's calculating around those. Shaded without edges. And then the regular transparency. All right, and then anytime we want to jump back into the standard display, we're just shifting display states. All right, any of the textures that get added out of the appearances, scenes, and decals. So and I'm not in. All right, so I want the body, the feature, the face, the part level. Notice that it's highlighting everything. Part level is doing what it said. It's going to apply bronze to that part level or to the component level. All right, so at the assembly, that one instance goes to bronze look, or all of them. Okay, and that was under work in progress, which I didn't want, so let's go over to the appearances. There's my polished bronze. And if I edit the appearance, then I can still come down and say, okay, apply that to all display states. All right, so over on, I always call it the beach ball, but the display manager, the very far left, view appearances, this is what we've applied for that display state. I come over to display state 2, I have more in the list. We go back to display state 1. Then I just have the couple that were by default. And then the same with any of the other appearances that we appearances or textures that we drag in to the part. All right. So it gives you a lot of power for visualization, not just going through the mates, going through the assembly, but then managing your configurations, and in the same conversation, really need to bring up the display states. Which reminds me, purge redundant. Let's see, properties for the display state. Under the display state, you also have the option that each new configuration will have its own display state specifically for it, or display states. All right, so more than one. Link display state to configuration. If I click on that, I should see under dynamic display state 4. It did not carry over all of the default. Without that box checked, then default and dynamic would share the same list of display states and be able to exchange those items. So let's see if display state 4 stays because it was added. It was part of the dynamic. It's not just going to go away, but now it's not exclusively for that one configuration. So it's one of those things you should decide up front so that it doesn't get too much mixed and matched. But whether you want to manage this at a configuration level or at a global level. All right. I will look into the linear coupler and the other one, and we'll revisit it at some point.